our basement remodeling situation, the hardest part of the mechanical systems installation is already done. We've got a hot water heater, a furnace, even a sub-panel for the extra wiring. Our job will be to add any additional connections needed for the basement.
The heating in this basement is forced air, and it's already been installed. It's called transite heating. The hot air travels to this duct through large PVC pipes that run underneath the concrete floor. The heat travels up through the duct, heats the room, and then goes back to the furnace through cold air returns. There will be a cold air return located in this wall. Now, this wall wasn't in when the heating was first installed, so it'll be our job to locate it and install it. By taking out a section of the top plate, we'll be able to use this stud cavity as the cold air return. Two pieces of sheet metal get fit around the gap in the top plate to help seal it up around the edges. This frame will form an opening in the drywall where the cold air can enter the stud cavity. And because this stud cavity will have other openings in the bottom for plumbing, I use a short 2x4 block to seal up the cavity below the opening. When sheetrock is installed on the ceilings and walls, the stud cavity will become an enclosed duct that'll feed air into the existing sheet metal through an opening that was created by the heating contractor when the house was first built.
With our heating system, adding on is fairly straightforward. The original heating contractor laid it all out. But if this preliminary work hasn't been done, we recommend that you hire a heating contractor to do this part of the job. There are complicated factors that affect duct size and register placement. The same is true for other kinds of heating, like a hot water system. If the pressures haven't been calculated and the pipes haven't been run, you should really hire a contractor to do this additional work in the basement.
Well, with the heating done, we can now start on the plumbing. Now, this can be a do-it-yourself job, but it's still a good idea to check with your local building department to see if you need a licensed plumber.
So you probably want me to turn the water off then, huh?
Not yet. Now, a lot of people think that. But because I'm only working with the drain waste vent system, not the copper water pipes, we can leave it on. First, I need to deal with the toilet. This PVC pipe needs to be cut down to the same level of the concrete floor. But before I do this, I want to chip off any high spots on the floor. This allows me to cut the PVC pipe down to size with a reciprocating saw. Now, I'm ready to install the closet flange. The procedure for making a PVC joint is always the same. First, I apply a cleaning chemical. This prepares the plastic. Then I apply the PVC cement. This actually melts the pipe a little, so that when I put the two pieces together, the joint is solid and watertight.
We've made a change in our design plans. We were going to put a vanity here, but now we want to put in a pedestal sink. But the elbow that was here wouldn't work with a pedestal sink. So we're going to replace it with this assembly, which will bring the drain pipe out square from the wall. This starts with a coupler to allow us to attach the two cut ends of the PVC pipe. The elbow assembly goes on next. A coupler goes on top of this. Then, by lifting up the top pipe, we're able to slip it down into the coupler. To install the drain for the shower that's going to go here, I have to work in this box that was built into the floor. To prepare for the drain under the shower, first I have to remove the 2x4 forms that the concrete crew used to create the box. There's a stubbed out drain buried in the ground here somewhere, so it takes a little excavation to find it.
Once we found the stubbed out drain pipe, we need to guess how much to cut back, so that the drain pipe will be 12.5 inches out from each wall. Then we dry fit the trap assembly onto the drain pipe. Next, we put in the riser. Once it's plumbed, I position it so it's exactly 12.5 inches out from one wall. This tells me I have to cut the drain pipe a little shorter so that the riser is the proper distance from the other wall. Now the first elbow gets glued into place. Then I attach the trap and riser. With the PVC cement setting up, I only have a few seconds to make sure everything's plumbed and in the proper position. And here's a tip. To keep sewer gases from backing up into the basement, I just pour some water into the drain. This will settle into the trap. All right, with the drain system done, we can start on the supply system. This will mean cutting into the existing supply lines that run to the wet bar in the den upstairs.
So now we're ready to turn the water off, right?
Well, not quite. We can leave the water on as long as possible by starting to install the supply lines at the fixture and then working our way back to the connection point. The supply for the toilet goes about 6 inches over and 6 inches up from the closet flange in the floor. So first I install a nailing block to mount it onto. The pipe that feeds the toilet runs along the bottom of the wall, so holes need to be drilled for it. This is a 1-inch drill bit, which will give us enough room for the 1/2-inch copper pipe. Now, whenever you connect pieces of copper pipe, you have to go through a very specific process. Both parts of the joint have to be cleaned to remove burrs and oxidation from the copper. For this elbow, that means brushing out the inside. For pipe ends, it means cleaning them with pieces of emery cloth. Then a substance called flux gets brushed onto the pipes. Flux will help the solder bond better to the copper. Our first assembly consists of an elbow to turn the lines out from the wall and a short length of pipe with a cap on it. All this fits on the end of the pipe that we ran inside the wall. To sweat the joints together, I heat up the area with a propane torch. I need to get the pipe and the cap pretty hot. Then I touch the solder to the joint. The heat and the flux draw the solder into the joint. Finally, I wipe the excess solder off with a damp rag. I repeat this process on each joint. The other end of this pipe gets an elbow to turn the corner and run into the second wall. All right, in this space, we'll join this pipe to the pipe that will run up to the shower.
Also in this stud cavity, we need to install some blocking to support the shower faucet assembly. And in this case, we're going to install the blocking so that it's flush with the front of the studs. This wall will contain most of the plumbing for the room, so it's often called a wet wall. The hot and cold supply lines will run down from the ceiling in one stud cavity. First, they'll feed the shower faucet